Okay, this tutorial is for those in my class who still just need one more review of the basics of quantum numbers, electron configuration, orbital notation, electron dot, and these are only through argon because remember the rules change after that. So let me go ahead and get started. Okay, you have this sheet. You can pick this up in my room so you can follow along, but this is going to just review real quickly. Remember, all of this is describing the location of an electron, and that location of electrons in an element is exactly what tells you how it's going to behave later when we start getting into reactions. So all of these configurations, all of these talking about how many valence electrons there are, that's going to come in really key. So that's why this is important. It's why you need to really kind of know this section because it's going to keep following us. But anyway, quick review. Okay, for quantum numbers, these describe exactly where, not exactly where the location is, because remember, these are still like my glasses. Remember the metaphor I gave you when I'm looking for my glasses, when I try to find them, I shine a light on them, and they move. Electrons the same way, so it's the most probable location. But anyway, first quantum number, of course, is that principal quantum number. And this is the most broad quantum number. This will tell you the energy level. We abbreviate it N, and that is the energy level. So N equals 2, N equals 1, N equals 3, so on, so on, so on. And so that's kind of like the layers on the cake. The next one is something what we call the angular momentum quantum number. I'm never going to write it but think of it more as the types of orbitals. Remember, there are 4 types of orbitals: SPUF, S, P, D, and F. And there's S's are spherical shape, and there's one of those per energy level. P's, they start in the second energy level, and they're kind of that dumbbell infinity shape. There are 3 per level, X, Y, and Z. The D's are when they start getting to the point where I start losing my capability of drawing them. They're kind of clover-like shaped, except for one of them. It's kind of ring, but again, these are most probable locations for an electron. As soon as we get to more of these kind of wonky-shaped ones, these are there 5 of them. This is what electrons don't really particularly want to fill them. They're kind of low-rent district. It takes a bit more energy to fill them, so that's why they're kind of farther down the periodic table. And then finally, the F orbital has 7 ones. We'll get into those later when we get beyond argon, but just know there are 7, and they are really wonky shaped. Not even going to try to draw them. Okay, so we can describe what energy level is in, 1, 2, 3, or 5. We can describe which orbital it's in. That's S, P, D, or F. The next thing we can describe is it's called the magnetic quantum number, and for all our intensive purposes is just going to be which axis the P is on, because your P can either be along the x-axis, the y-axis, or the z-axis. There are magnetic quantum numbers for all of them, D and F also, but we're not going to so much worry about that. Next year when you take Chem 2, then we'll worry about it. And then last one is the spin quantum number, and this tells you exactly the most specific, not exactly, but the most specific probable location of your electron, because electrons will either spin one way or another. So that's how we denote the arrows, because again, that's electrons in order to kind of be able to be in an orbital together. That one spins one way, one spins another, generally. Okay, so there's our 4 quantum numbers, and now we put all 4 of them together in order to do 3 different notations. One is an electron configuration. One is an orbital notation, and another one is the electron dot, and we'll talk about that one in a little bit. But electron configuration is one in which it kind of gives you an address of the most probable location of that electron. Okay, and the way we write them is first we say the energy level. So we would start with energy level 1 because it's the closest to the nucleus. Remember, electrons are lazy. They like the lowest energy, so the first one would fill that first. Then of course, the first energy level only has the s orbital. So that would be the first way you would fill it, 1s. And how many can it hold? It can hold 2 electrons. So as soon as you have 1 electron, it would go there, and then 2 electrons would go there. Now, as soon as you fill that, it's all full. Where do we go? The next energy level, which is the second energy level. Second energy level has both s and 3p orbitals. S is always filled before p's because they are lower energy. Remember, it's always lower energy. Lazy electrons, lower energy. Okay, and so we have 1s2, and so then the next step would be to go to the 2s, and again, how many will it hold? 2s2. After this is when we start getting into the p's. Remember, we said there are p's in the second energy level. So we would go 2p, and how many p's do we have? 3 of them. 2p, 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 and we call those x, y, and z, okay? And again, each of those can hold 2, but the last thing you have to remember when you're filling these, they fill one at a time. They don't really want to live together if they don't have to. So let's say we have, okay, so far we've got how many electrons filled here? We've got 2, 4, let's say we have 2 more electrons to go in. It's not going to go 2px2. That is not going to happen, okay? Because again, if they can live separately, they will. This is my px, got it, okay? So instead, it's going to go 2px1, 2py1. All right, so that's how those fill. They fill individually, okay? All right, and then you would just keep filling. If you had more, 2px1, 2py1, 2pz1, then we would go back with another electron and go 2, 2, and 2. Once you fill that, then you go up to, that's all full for the second energy level. That's full now. Now we have to move up to the 3s. And how do we start an energy level? With the s's. So again, it'd be 3s2, and then we go on to do all the 3p's again. Okay? All right, so that's generally how we fill. I'm going to do some examples later, and so hopefully you kind of see this. Okay, orbital notation is just a physical representation of the electron spin. So orbital notation is this weird thing where you either draw a box for each individual, again, I like to kind of do, for the p's, I like to group them. You're going to draw a box for every single orbital. So for here, for 1s2, I would go arrow down, arrow up, representing one spinning one way, one spinning another way. Another way you can denote it is with one spinning one way, one spinning another. Now with their p's, remember, when we filled them, we fill one at a time, and then we come back and pair. Now if we wanted to go, you can also, sometimes you'll see them as circles. That's okay. And sometimes you might even see them as lines. Any single one of those I would take, because they're all the same representations. But just make sure you denote one spinning one way, one spinning the other, and you split up your p orbitals because they fill one at a time. Okay? All right, so that's electron configuration. How you do that? 1s2, 2s2. Orbital notation, that's the boxes and the circles with the arrows, denoting one going in one way, one going the other. Electron dot diagrams. This is when we show the valence electrons. Remember I said we're going to do this over and over and over and over. Valence electrons are the outermost electrons. And the general idea of how you do an electron dot diagram, you only look at the outermost energy level. And so that's going to, and then you put the symbol in the middle, and then the S goes here, any electrons in the PX go here, PY, PZ. Okay, so that's the generalized notation for electron dot diagrams. Again, only looking at the outer energy levels. Okay, let's do some examples. Carbon has 6 electrons. We're going to do all 3 notations. First of all, we're going to do electron configuration. What do we do? Okay, 6 electrons we have to fill. They first go in the first energy level. 1s2. Now that's full. Where do we go? 2s2. Now we've got 2 more electrons left, right? Because 2 plus 2 is 4. We got 2 more left. They're going to go into the 2px, 2py, and we have 1 of each. Okay, again, remember, they don't like to live together, so go 1 and 1. Okay, how do we do orbital notation on this? circle or box for each one. And again, I like to put the P's kind of together, and so we have one of each. And now, done. Oh, that's the orbital notation, one in each of there. And how would we do the electron dot? Carbon goes in the middle. Okay, and now remember, we only look at the outermost. So here we have the first energy level, and here these are all second energy level. So we are going to go ahead and cross that out, not even going to look at it, and work. So how many do we have in the S? We have 2. So we put 2 dots there. How many in the PX? 1. PZ, or sorry, PY, 1. So the electron dot looks something like that. Okay, neon. Why don't you go ahead and do it? Pause, and then come back, and I'll have it, I'll write it out for you, and you can check yours. Okay, hopefully you've written it out. And let's see if it looks like mine. Did you do 2p6? You can do that as soon as, if you did 2px2, 2py2, 2pz2, you can go ahead, as soon as you realize that that is filled, you can go ahead and just round it off at 2p6. We really only need to split it up when we have individual orbitals here, okay? And then, but when you do the orbital notation, yeah, you do need to include all 3 orbitals, because remember, the p's are 3 p's, okay? And then, of course, neon would be any in the middle, and then we got dots all the way around. Why all the way around? Because we've got 2 here, 2 here. Remember, don't look at the 1s. Okay, go ahead and do magnesium and then come back. All right, we've got 1s2, 2s2, 2p6, 3s2. And so get an orbital. One, two, 1, 2, 1, 2, 1, 2, 1, 2. And magnesium looks like this. Symbol in the middle. Remember, we're not going to look at any of these. We're only going to look at the 3s now because that's our outermost energy level. And so we put 2 right there. All right, last but not least, go ahead and do sulfur. Come back. All right, and it's 1s2, 2s2, 2p6, 3s2, and now how many do we have left? We've got 4 left, right? And so now we're going to go 3px, 3py, they're running out of room. Okay, and remember we got 1, 2, 3, 4, so it's 2, 1, and 1. Sorry, this is getting sloppy. Orbital notation. And 3s2, and we got our p's, our last set of p's here, 2, 1, 1. And last but not least, our electron dot. Again, we're not going to look at any of that right there. Only what's in the 3rd energy level, because those are the valence electrons, outermost electrons. 1, 2, 3, 4, 5, 6. And so there you go. There's the electron dot for sulfur. All right, hopefully this helps. I will put up a new tutorial after to do post-argon, because, again, the rules change. But I'll try to get that up tonight. We'll see if that happens. But okay, I hope this helps.